Hey everybody. So I had another person request of 8-2, and since I have not done 8-2 yet, yeah, here we go. So 8-2 is on similar polygons. It is setting up not just triangles that are dilations of each other's, but actually something else. Maybe it's a rectangle or a square, or maybe it's just some kind of odd looking shape that has been either enlarged or reduced in size. So you have similar figures. And we're going to set a proportion, cross multiply, and solve. We're also going to talk about the similarity ratio. And we call that in high school geometry scale factor to see if they come out to be the same number. If they are to scale, pretty similar to like a true vehicle and a matchbox, type toy. Yeah, then they're similar to each other. Okay. Let's see what we got here. Oh, by the way, if you're wondering what this little symbol right there is, that is the symbol for similar. All right, well, so two things have to happen for polygons to be similar. First, the angles have to be congruent to each other. I'm talking about angles that are sitting in the same position. And their sides have to be proportional. That would be the same scale factor. So two things have to happen for them to be similar. Now, what I mean by angles sitting in the same position is going to be talked about here in example 1. See how they say A, B, C, D? In that order. A, then B, then C, then D. They also say P, Q, R, S again in that order. P, Q, R, then S. Order matters. What I'm saying is whatever letter is first in your first figure and whatever letter is first in your other figure, I don't care if it's an enlargement or a reduction, they're equal angles. So angle A and angle P are equal to each other, angle-wise. B, that's the second letter, is going to be matched up with Q. They are going to be equal angles. C is the third letter. R is the third letter. They are equal angles. And D is the fourth. S is the fourth. And they are going to match up D and S. Those angles are equal. So order matters, and that is how they are congruent to each other. So angle A is congruent to angle P because they're both first. So let me go to geometry to get my angle symbol and P. All right, B is the second letter. It's going to match up to Q, which is the second letter. So it literally is just that easy. Most of my students are like, that's it? That's all I got to do? Well, yeah, when you're just matching up letters. All right, C is third. It goes with angle R. That is also third. And of course, that really is going to help you set the problems up. All right, D is the fourth letter. It matches up to angle S, which is the fourth letter. So it's not just, as simple as, hey, I'm matching up things in the first, second, third, and fourth position. All right. Okay, so there's your congruent angles to each other. And below that, they show you guys how to match up sides, which is probably what we're going to do in that next check. All right, so here we go. Check. NPQR similar to UVST. List all pairs of congruent angles and write a proportion that relates the corresponding sides. Okay, so angle N is what they say first. That is the first letter. So what matches up to the first letter in the reduced figure? U is correct. So angle U. All right, then they say P. P is your second letter. So what angle matches up? Angle V. Angle Q, they say third. So what angle goes with the other? Angle S. And angle R, that's your fourth letter, 1, 2, 3, 4. So it's going to match up with T because it's the fourth letter, 1, 2, 3, 4. So angle T. If you're sitting there wondering, now hang on, there's got to be more to it than that. Absolutely, that's true. Okay, Now we're talking about side proportions. Now I tell my students that I am matching up not just one letter, the first one to the first one, I'm matching up 2 letters. NP, because N to P is the side of the figure, because this figure has 4 sides, NP, PQ, QR, RN. The first 2 letters, which are NP, will match up to the first 2 letters in the other figure, UV. So NP and UV are the same position. Are they the same size? No. So it's not like angles. Angles that are in the same position are congruent. These are going to be proportional. What I mean is we're going to do a ratio. That is a comparison of 2 numbers. It's going to look a lot like a fraction. All right, so NP, my first 2 letters go with UV. NP, oops, and UV. What if I move this over? Okay, don't need to. All right, so NP went with UV. All right, now the next side is PQ, which is your second and third letter. So NP, this side, is going to match up to the second and third letter VS. PQ, VS. All right. The third side is QR, which is the third and fourth letter. So it's going to match up to ST because it's your third and fourth letter. QR, ST. And the fourth side of this figure is RN. So it's NP, PQ, QR, then RN, which is the first and fourth letter. It will match up to the first and fourth letter in the other figure. So RN, NR, will go with UT. All right, there are, oh my gosh, that is so small. Those are our proportional sides. Sorry that's so small, everybody. I'm not sure how to even fix that. Example number 2. Okay, so we are on page 470 in the middle of the page, example 2. And it says identify similar polygons. Determine whether triangle NQP is similar to triangle RST. If so, find the scale factor, explain your reasoning. All right, one more time. For these 2 triangles to be similar, they have to have congruent angles. So I see angle N and angle R both have a little 1/ arc. That means they are congruent to each other, and that's true because your first letter and your first letter will be equal. And I see Q and S both have 2 red slashed arcs, and Q is my second letter, S is my second letter. All right, so which means P and T, those angles, angle P and angle T, should be the same. Now, I don't know what their measures are, but if I've got 1 angle and 2 angles, then 3 angles should be congruent. Okay, let's keep going. All right, so step 1, compare the corresponding sides. All right, so, oh, no, I've already done that, step 1. Step 2, all right, compare the corresponding sides. All right, here we go. The first 2 letters are NQ and RS. So NQ is 12.5. That's why they have that one on top. It matches up to RS. RS is 10. And 12.5 divided by 10 simplifies to a 5/4 scale factor. Okay. The next one, QP. Those are your second and third letter. It has to match up to ST because S and T are your second and third letter. So you visual people, QP, 11.5 goes with ST, 9.2. And 11.5 divided by 9.2 simplifies to a 5/4 scale factor. All right, last one. The last side of this triangle is NP. Visual people right there. There's your 15. NP matches up to RT, and that's 12. So 15 divided by 12 simplifies to a 5/4 scale factor. And since they're all 5/4, this triangle in QP is in fact similar to triangle RST. Equal angles and the same proportion in sides. Okay, so we got a check on the same page, page 470 of your workbook. All right, and it's asking us to determine if this quadrilateral, A, B, C, D, is similar to this quadrilateral, E, F, G, H. If so, find the scale factor. Okay, well, first two letters, because I'm not even going to worry about angles. They're all 90. They're all 90. They are equal. Are AB, and that has to match up to EF. I'm going to put 10 over 14 and simplify. 10 divided by 14. All right, y'all, they both divide by 2 because they're even. 10 divided by 2 is 5. 14 divided by 2 is 7. So it appears the scale factor is 5/7. All right, let's keep going. All right, BC, that is your second and third letter. It has to match up to FG because F and G are your second and third letter. So I'm going to put 8 over 12. 8 over 12. Okay, this is going to simplify. Let's see. It's not just a 2 because I have a number 4 that I can go in both of those. 8 divided by 4 is 2. Oh, let's back up. 8 divided by 4 is 2. 12 divided by 4 is 3. Okay, so it appears that these are not to scale. They are not the same scale factor. 10 with 14 gives you 5/7. 8 with 12 gives you 2/3. Not the same scale factor. So yeah, they have equal angles. But as I said earlier, it takes 2 requirements. Equal angles and proportional sides. And these are in fact not proportional. So our check, big no. All right, let's move on. Example number 3 on page 471. Okay, says use similar figures to find the missing measures. All right, this is your pretty typical, hey, let's set up a proportion cross multiply and solve problem that you probably did in middle school with triangles. But this time we have some sort of, man, it looks like a trapezoid. In triangle, I'm sorry, I was saying triangle. In figure, WXYZ is going to be similar to PQRS. Find the value of Y. Well, it looks like Y is in an expression that represents a side from Z to Y. And Z to Y is your fourth and third letter. It has to match up to the fourth and third letter RS, and that's a 6. So we're going to have 5Y minus 2 over 6, if you're wondering why they did that. Because there's your Y right there. That's what we're trying to find. It goes from Z to Y. That's your third and fourth letter. Third and fourth letter RS matches up to the 6. Okay, back to it. We got a 16. And that's going to match up to the 12. And if you're wondering why, WZ is your first and last letter. And it has to match up to the first and last letter, PS. That right there, ladies and gentlemen, is your 12. So 16 divided by 12. All right, we're going to cross multiply. Pretty typical. 16 times 6. 12 times 5y minus 2, which is a distributive property. 16 times 6 is 96. 12 times 5y is 60y. Oh, and 12 times negative 2 is a negative 24. Okay, let's see what we got here. Okay, so we're going to add 24 to the opposite side because we have a minus 24. So the inverse operation is to add 24 to the 96. And let's see, what's 96 plus 24? 120? The opposite of multiplying by 60 is divided by 60. And 120 divided by 60 is 2. All right, you guys, so the answer, find the value of y. Y is a 2. All right. Got to check at the bottom of the page. In the diagram, triangle JLM is similar to triangle QST. Remember, order matters. You're going to know that to set this problem up. Find the value of x. Round to the nearest tenth. Oh, my goodness. Okay, students. Hey, can I get a decimal? Yeah, you can get a decimal. And you're going to round to the nearest tenth. Okay, here we go. Where's my x? All right, it's on the side that runs from L to M, which is my second and third letter. LM is going to match up to the second and third letter ST. So that means 6x minus 3 will be over 3. All right. Then I got to figure out what matches up again. And if you'll kind of look, that I have a number between the first and third red arc. I want to match it up with the first and I said third. I don't know why I said that. That's 2 red arcs. The first and second red arcs, and that's going to be 2. So this 5, not there for anything. And if you're trying to figure this out, SQ is the first and second letter. It matches up to JL, and there's nothing over there for JL. So if you're getting stuck and wondering, okay, what do I match the 4 up with? It runs from J to M, which is your first and third letter. It has to go with QT because it's your first and third letter. All right, so that means 4 is going to be over the 2. So 6x minus 3 over 3. 4 over the 2. The 5 is junk information. We do not need it. Oh, and I love it. They don't give me enough room to write this. God, okay, so 6x minus 3 over 3. And then I said it was 4 over 2. All right, we're going to cross multiply. All right, so we're going to multiply 2 times the 6x minus 3. And then we're going to multiply 3 times 2. My bad. 3 times 4. I don't like it when it looks like this. I can't see it very well. All right, so, good grief. That should be an X. Okay, golly, I'm just making all kinds of mistakes. Distributed property. 2 times 6x is 12x. 2 times negative 3 is a negative 6. 3 times 4 is 12. All right, the opposite of subtracting 6 is to add 6 to the other side. 12x. 12 plus 6 is 18. The opposite of multiplying by 12 is to divide by 12. So let's see, 18 divided by 12. Oh, what's that? Well, it's 1.5, isn't it? Because 12 is 24. Half of that would be 6. It would be 18. So it would be 1.5, 1.5. So x is 1.5, everybody. 1.5. All right, moving on. All right, what we got here? Oh, we got an example 4, which is a word problem on the next page. So everybody turn to your page, page 7. Oh, golly. I'm having an off day with my numbers, y'all. Sorry, I'm a little bit dyslexic. It's 472. 472, not 742. All right, example 4. All right, so we got it from the perimeter. Jeffrey plans on going to the state fair this summer. He has downloaded a map of the fairgrounds that shows all of the attractions. Jeffrey plans to visit the concert hall, right there, the Ferris wheel, and then the sports center. On the map, the distance between the concert hall and the Ferris wheel is 9 centimeters. The distance between the Ferris wheel and the sports center is 8 centimeters. And then the distance between the sports center and the concert hall is 4 centimeters. So 9, 8, 4 centimeters. All right, describe his path. All right, so what polygon can we use to model? That would be a triangle. because there's 3 of them. 9, 8, 4 centimeters. Okay. So we're talking about similar figures, because obviously the map is a scaled drawing of an actual place, the state fairgrounds. So let's see. We're looking at similar figures. All right, it says because 1 meter is 100 centimeters on a map, 20 meters is equal to, well, let's see. Let's do a multiplication here. That would be 2,000. All right, so C prime S prime is 2,000 centimeters. All right, so the scale factor, remember this is just a comparison of two numbers. 2,000 divided by 4, that would be 500. All right, now they're talking about perimeter, so we're going to add 4, 8, and 9. I'm not sure why they're doing them out of order, but fine, whatever. That's 21. And if you're wondering where I got that, remember this was 9, 8, 4. 9 plus 8 plus 4 is 21. All right, here's where we're going to set up our proportion. 1 out of 500. If you're wondering where that comes from, 1 out of 500 comes from knowing what the scale factor is. Perimeter of the regular triangle, CSF, in comparison to the perimeter of the image triangle, C prime, S prime, F prime, is 21 over W. Again, if you're wondering where that came from, 21 right there. All right, we're going to cross multiply. So 1 times W is W, and we're going to multiply 500 times 21, and that is going to be, what's that, 5 times 10,500. 10,500. All right, oh, there it is. So the perimeter of CSF prime triangle, 10,500 centimeters, or, well, 105 meters. Oh, we are done. All right. Whoever you are that wanted 8-2, I hope this helps. And if you have any questions, let me know. The practice is all of you guys. Yeah, good luck. Y'all have a good one.